Have you ever wondered how electrical engineers and designers create modern-day blueprints for buildings? Well, this video is an overview of the Autodesk Revit software showing how we designed an electrical system for a 3-story, 30,000 square foot college classroom building. So you will see how we assemble all these parts and pieces of receptacles and switches and lights and panels and switchboards all together into a smart 3D representation interconnected with smart schedules. So stay tuned. So I've got Revit 2022 open here, and I'm using this older version because this project was actually designed and completed in Revit 2022. So you want to use the same version of Revit that your model is in. So we're going to go here to Open Model. We have an existing model to open, Open Model, and then you navigate onto your server, or if you're cloud-based, you would be in the cloud opening up your project. And this one here is named by the project name. It's called Electrical, and we put a 22 to indicate that it was done in Revit 2022, as you can see here on the right. So we will open this. One thing to note is that down here there's a thing called work sharing, and this is something you can turn on or leave off in a model, and it allows us to work share this project with other people at the same time. A number of us on staff can open this electrical model and actually draw in it, model in it at the same time. So what this does is it's a central model located on our server in this case, or it could be on the cloud. And then we are creating, this checkbox says create new local. We're creating a new local copy onto my PC of that central model so that I can work on it. And then every so often it will synchronize or sync my local model with that central model. And it'll also bring information from other people that have synchronized from the central model to me. So it keeps us all in synchronization. So let's open that up. And it'll ask you, do I want to create a new local copy with the same name? Overwrite. Yes, I always want the most recent version of our model copied onto my local PC. So this will take a minute and we'll zip through this quicker. So it's open now, and it gives us this very nondescript starting view, which is just a text view. Some people will put information about the project in this view, but this was done a couple years ago, so we didn't have all that here. But let me show you the basics of this. This is like a typical Windows program where you have a ribbon up top and of course tabs above that. So what we have is a couple windows in here. On the left, this one is called Project Browser, and it can be moved anywhere you want. I have it on the left side. It is like an Explorer type of view of everything that's in this electrical model. So we've got different views. We've got things called legends, which can be like symbol lists and things like that. They're like a two-dimensional detail. We can have schedules in here. Lighting fixture schedules, mechanical equipment schedules, and we even have some technology schedules. We have panel schedules, and you can see these are by name. We have 1, 2, 3, 4, 5, 6, 8 different panels in this project. And then we have our actual sheets that get printed to PDF or even to paper. So they are listed by drawing name and title. And if you click the little plus, it tells you what views are in that sheet, because we just take floor plans and legends and 3D views that we create, and we drag them and put them onto an actual sheet. So I'll show you how that's done. But here's all of our sheets, all arranged nicely in order. And then we have the building blocks of the model called families, and they are listed, let me close some of these, they are listed by category. So Revit is big on categories. If we go into annotation symbols, even under annotation symbols, you can see here's a bunch of some of our technology symbols. And then down here, you get to our electrical symbols. And these are just symbols. They're, for example, down here we have one-line circuit breakers and all of the one-line diagram symbols. These aren't 3D families or anything, they're just symbols. I'll show you how those work. But this is where all of the families are stored. And so we'll get into those. And then there's things called groups, where you can combine things all into one piece. And then we also have links. And you'll see right here, this is actually a architectural model that is linked into our electrical model. I'll show you how that works. So let's start right now with look at some of these views. And they're arranged by discipline. So we're going to look at our electrical views. And there's a bunch of them in here, so I'm going to close some of these down so we can kind of start looking at these without being overwhelmed, because you start digging into this and there's quite a bit here. Now this is my distribution view, so it's going to show conduit and such, but this gives you an idea of the building. So you can see here that we've got concrete footings, slabs. This is an exterior view, and we've got canopies and roofs and windows and all the architectural stuff. We even have this stairway over here. Now, dash typically means it's going to be removed, but this is all in from the architect. And if I click on that, you can see it highlights blue, and I hover over it, and it's called a Revit link. It's a linked Revit model. This is the architectural 3D model that we have linked into our model, kind of like CAD had XREFs. So we start with that, and then we add all of our pieces. And all of our pieces, this is just showing distribution. But for example, a main distribution board, it highlights when I hover over it, or I click on it. Over on the right side, we get this huge window called Properties. This will show us the properties of this one piece of equipment. And as you can see, there's a lot of parameters within this. This is the information in a BIM model, Building Information Modeling. So you will see that it has loads, currents. It breaks them down by HVAC, lighting, motors, receptacles. So this is all done intentionally when we connect things to have it broken down. We've got switchboard dimensions. We've got the panel name, 4MDB. And then we have some circuiting. It's a 1600 amp rated. There's 18 three-phase circuits in it. And it's 480 volt 277. That is just one piece of this puzzle. Down here we have a transformer. And it's a dry type transformer, and it has all the ratings. It tells us what the secondary distribution is. In this case, you can see that it's in 3 dimensions. It doesn't have to be. This can be done in 2 dimensions as well. But in this case, we like 3 dimensions with large feeders so that we can do some space planning, some coordination, clash detection with other trades. And we have a large transformer sitting outside. But that kind of gives you an overall view of this 3-story, 30,000 square foot college classroom building. And if you're getting something out of this, please hit that thumbs up like button below. And if you want to see more electrical only content, hit that subscribe. I appreciate it very much. Back to the video. What I'm going to jump down to is a lighting view. Down here, lighting. And they're called ceiling plans. Typically in buildings, we have a set of plans called a reflected ceiling plan. Let me show you here. It's a floor plan view. We're not looking up. We're looking down, but it's being reflected onto the floor. Is why it's called a reflected ceiling plan. It's like the floor is a mirror. But in this, you can see we have this interesting shape of this building. As you can see, each of these lights are an individual little symbol, and they each have their own data on the right. This is a suspended circular F1. It's been circuited up, so it tells me here that it's panel 4A1, circuit number 6. So we were able to connect that to a panel, and it keeps track of that. I can adjust the stem length in this version. And then if I go into this edit type, I get a bunch of other parameters. So it's full of data. It seems overwhelming at first, and it is, but eventually you start to understand which data is most important. And this one here, for example, load classification, I can classify this load as a receptacle, as an elevator, or as a lighting general. I can click on this and I can see a number of different load classifications. It can be EV charging, HVAC, and this will put things in categories, and it will actually apply what's called a demand factor. Like here, it's using a demand factor called general lighting. We can use a demand factor of receptacles, which follows NEC code rules like 10,000 watts plus half the rest, things like that. 125% of the lighting load. All that is done automatically here behind the scenes. We select the voltage that this can be connected at. What kind of lamp is it? What's the load of this fixture? Now, and this is called type. It's a type F1. And down here under a thing called type mark, that's what I'm calling it, is F1. Now that is what shows up in this little piece of text here, which is actually not just text. It is a smart tag. So up here, lighting fixture type tag. This tag is set up to reflect that type mark within this light fixture. So if I were to change this light fixture right now, if I edit it and say I want to change it to an L1 instead of F1, hit enter, the tag automatically changed to L1. And every other L1 fixture in this model turned into an L1. You can see how powerful that is. Now, if I also was to go in here and edit the type and change the parent load, let's say I found out I'm not using a 30 VA, 3000 lumen fixture. I need a 40 VA fixture. So put 40. Apply that. Okay. Now, every single one of these, if I edit it, now says 40. And that is reflected into that circuit it's connected to. We don't have to go through and count up how many lights we have and what wattage they are. All of these lights that are connected together get added up automatically. So that is very powerful here. So you can see we have exterior lights. Now these are all custom families with custom symbols. The ones out of the box may serve your purpose at first, but we found that early on, we want the symbols to look like frankly, our old CAD symbols, which we're used to. And we want them to have certain things. Like, for example, this light fixture here, if I click on it, under graphics, there's a little checkbox here called emergency. I can toggle the emergency filled in circle on or off to indicate, and that's how we indicate whether it's emergency light. So we've added that feature to this family. We've also created custom tags. As you can see, you can have wiring shown. It automatically will add this wiring and put an arrow on it, and it puts these little tick marks for conductors. We can customize what those look like. We also have little switches shown. Our firm uses a kind of a note to indicate lighting control. So lighting control 3, and then we refer to a legend that explains lighting control 3 may be simply an occupancy sensor type of control. LC4 is something else. So that's how we do it. But you can use whatever scheme you like. But you can see some other lights. We have some other emergency lights that are dashed in for a recessed 2x2. So we have all kinds of lights. Now, if you want to know how this looks in 3D, let's take a look at this lab school room in 3 dimensions. And one thing we can do is we can hold our cursor down, highlight this area, and then up here under view, there's a neat little thing called selection box. You click on that, and you can see this gets huge, but it drew a box around that area. So let me get navigated properly. Let's find a corner view. Now you can see there, it created a 3-dimensional view, and it cut the walls for us so that we can see inside the building. Now, this blue outline right here is called a section box. I can click on that and then use these little arrows to move that cut line. So I'm creating a section on the fly. I'm even cutting through the lights. Now let me pull this back out. I'm going to move the ceiling down. Now you can start seeing some of the grid waffle type concrete ceiling structure. But I can move it down a little bit. There we go. Now we can see lights. And then, all the doors and columns and everything's in here. Even some of the receptacles show up here. As you can see the face. If I turn this to thin lines, it becomes a little more, and that's actually, I think, a switch. Let's get the floor moved down a little bit. There we go. Now we're starting to see some of the floor. It has steps in it. There we go. Anyway, you can see this gives you a great visualization of what the room looks like, which is very helpful when you're designing it, instead of having to rely on just the architect's sections or elevations. We also have control over how this looks. Right now it's kind of a shaded view with colors. We can go to just a hidden line view if that's clearer. We can even go to a wireframe. So there's different kinds of views. We can go to shaded, which is what we had, and there's one called consistent colors. So, the architect applied colors and materials to their walls, and you can see this is multi-layered walls. And a lot of our electrical is just gray, but it can also have materials assigned to it. We're not trying to do realistic 3D rendering for our electrical purposes. We're mainly doing this for space planning. So that's how the lighting plan works. And again, you can see how it's all circuited together, and we're able to control these arcs that they're placed. I can move that out. I can add more vertices if I want to make it an S-shaped. I can pick where it hits this fixture. I can move this attachment up there if I like. I can move all these tags around. Again, they're smart. We even have smart room tags. If I get rid of this room tag right here and I want to annotate, hit room tag up top, I bring it in. As you can see, it automatically finds this blue shaded area is called a room. It automatically finds the room. And if I move it over to here, up here, it automatically changes to office or changes to corridor. So room names are easy to put in as long as the architect has named that room in their model. And this reflects the name within their model. So we don't have to type in text room names. One thing I want to show you before we get too far is that each of these floor plans is created or tied to a level of the building, an actual elevation of this building, because this is a three-dimensional building and we want the floor plan to look like a cross section horizontally throughout the building. Let me show you an elevation, the south elevation of this building. So this is just a rough elevation. It's got everything turned on. Right now, I'm just going to use a coordination button to turn off the X-ray vision. There we go. So this is a rough view of the building's south elevation. Now, what I want to show you is these things here, and they're kind of doubled up, but they're called levels, and they have an elevation associated with them. So level 1 ends up also being floor 1 in this case. This is typically set by the architect's model to let us know where the floors of the building, what level they're at. It also tells Revit how to create the floor plan. Now, we have these levels and even a roof level, and sometimes you'll have levels in between here, like a ceiling level or a mezzanine level. There can be many levels in here. And we say, I want my floor plan, I want that lighting floor plan to be based upon level 1. Down here, there's a associated level 1, and it's tied to that. Where does it cut horizontally, like a section, cut through the walls of this? That is determined by a thing called the view range. Right here, view range. If I edit that, if I show a little picture, here's a section of view range. So what we have is we have a lot of different things, but the main thing is this blue area. This red line here is called the bottom of the view. That's how far down of that level we want to see. We want to see to the floor. And then this line here up here is called the top. How far up do we want to see? And then this center line here too is called the cut plane. It's taking a saw cutting the building as a cross section right there. So it's cutting through the windows, it's cutting through the doors, and that is how it determines what shows up in this plan. And as a ceiling plan, lighting plan, it's also looking up and showing us the ceiling texture. When I get to a power plan, you will see that we're going to be seeing more of the floor than the ceiling. Levels are a primary aspect of these models. So let's go ahead and take a look at a power plan. So under here, under power, floor plans, you can see there's a bunch. Now, some of these floor plans we have in lowercase, and these are just what I would call working drawings or coordination drawings that don't actually get put onto a sheet and printed. Maybe they turn on other trades, like turn on the plumbing or the HVAC, so I can coordinate with them. But the main views that we drag onto sheets we use capital letters for that. So a site plan, for example. This is set up, and you can see all these little these are section cuts that won't print. But we use those when we're modeling the conduit. But this is just set up to show the exterior items on the site. So we have this existing 1500 kVA transformer, and we have brought new feeders, service laterals underground into our main electrical room with the main distribution board. So these conduits show up, and if I go to this section, I can click on it. You can see here is a section, and it shows these conduits. I've modeled them in 3 dimensions coming from outside up into our building. And then on here, they just show up as lines. But if I go to first floor power, double click that and open it, now you can see this is more of a power view, and we break up our project into different views, all derived from that one 3D model. So all these pieces exist in the one model, and we just make them visible or not in different views. So this view, I've turned off the lights and I've turned on the receptacles. And again, we have circuiting. We can have symbols for notes. We have, even in this case, we have revision tags, and you can see a little cloud for revision. So we've just gone through and placed these receptacles that actually get mounted to walls. We've got fan coil units, mechanical equipment, HVAC stuff here. labeled. And again, this is a smart family that has data. If I hit edit type, we have 62.4 VA motor load. It's a 208 two-pole, so single phase 208 two-pole connection. We've classified it under HVAC. And so we've also set this up to show up in a mechanical schedule. So as you can see, this is all just individual parts and pieces that get assigned circuits so that it can add up the circuits for us. Again, smart tags can have leaders. So this guy can be moved around and then the leader follows it. And even on text notes, we can just put text if we want to, like this one. This one's just text. As you can see, it's text, 330 seconds Arial, and you have ultimate control over the text. I can change the color, line weight, is it opaque or transparent? Dimensions of leaders, what kind of arrow is it? Do I want a box or an arrow? Is it 15 degree, 20 degree, 30 degree? You have ultimate control over the view. Plus, of course, fonts, text sizes, width factors, all the text type things. And then we also have leaders. We can add leaders up top here. Let's add some more leaders. See, it's adding a bunch of leaders, and we can get rid of leaders. We have ultimate control on where these leaders bend and where they end up. So lots of choices with text. This power plan also highlights that in 2 dimensions floor plan, this receptacle is just a symbol. You don't see a box or a face. However, if we do decide to do a 3D view with that little trick I showed you with the box, now, and this is a very small view that I made, but now you can see that this receptacle is actually a 3D entity inside this model. Let me turn thin lines on so we can see it. But see, it's kind of representative of a receptacle. It has a cover plate, and there's actually a box hidden behind in the wall, and a couple circles in the face. You can make that as detailed as you want. So we have a 3D piece that has a mounting height over here. It's 1'6" above the level. So it's full 3D if you want, as well as the 2-dimensional symbol. Some people just do 2-dimensional plans, and that's perfectly fine. I have other videos that show you how you can customize some of these families to just be 2-dimensional if that's all you need. It's very adaptable. Let's look at the circuiting again. I want to show you what the panel schedule looks like. So we created a panel up here. We have panels, and you click on a panel, and again, it has a bunch of data, and it has a name, panel name associated with it. But we can create a panel. Up here it says create panel schedule, and it creates a schedule of this automatically for us and fills in all of our circuits that we connected things to. So let's go down to panel schedules, and let's look at this panel 2A1. Double click 2A1. Up pops a panel schedule. Now these are also customizable. You can change kind of the display of this if you like things stacked differently, or if you want multiple poles combined. There's a lot of control here, and I have videos that show how to do that. But this is an 84 circuit panel, and we've put these labels in. We can change the label. If there's multiple offices, I can list them here, like here, and this is all just text I can type in here. I can change the trip rating. But the load, I can't change here. It is automatically brought in from my plan view. When I connect receptacles together and send them to this panel, it adds them up, and it lists them here. And at the bottom of this, it gives me a list of all of my loads based upon those load classifications that I selected. So it puts all the equipment together as connected load, HVAC, other motors, and receptacles. It applies the proper demand factors. And like here at receptacles, the resultant of 10K plus half the rest ends up being a 63.96% demand factor for this demand. And so we have all of our totals, like you might have done in Excel. Connected load, the estimated demand, connected load in amps, and demand in amps. And we have the connected load by phase as well. Have some ratings up here for mains, main bus, and for main circuit breaker. We can specify whether it's a surface, what's the enclosure type. All these things can be put up here. We can add AIC rating if we want to. Some people do that on the single line, one line diagram. But my point is that if I were to go in and change, like I did those lights, if I change the lights to a different wattage, it adds them up. So let me go to 480 volt 277 panel. And as you can see here, lights, it's added up all the lights, 1070, 852. It's down to the VA. And as I changed those lights from 30 to 40, it bumped up the connected load, all behind the scenes. And furthermore, we can connect all these panels to a main switchboard, for example. We have a 4MDB. If I look at that, it's a different style of schedule. We treat it as a load summary, but it has our 3 480 volt panels, which, by the way, are subfeeding a transformer and then a panel, a 208 panel. And we also have our elevator. So we have all of these loads here. It adds them up again for the entire building. Here's my load summary for the entire building, broken down by load classification. This can be handy to give to the utility company if they want a breakdown, load by load. And then here we go, our total estimated demand on this building. So that happens all in the background and automatically updates as you change things in the model. Now let's go back to that power plan. And I want to show you this electrical room. Now, I can see this electrical room in 3 dimensions if I like, a few different ways. I can surround it and do that little view, or I can actually, up here it's very powerful. There's a section. I can cut a section anywhere, anytime, and just pull a section right here. There's the symbol. Double click on this and I get a section, and we can set this up however we like, and we can turn things on and off. But let me just jump here to make it. Let's just go to an architectural elevation and see how that looks. There we go. Now here's our electrical room, and right here you can see we have a transformer, and we can change the display of this to go to a fine level of detail. And then we will see our 3D panels and our transformer. So this is good for showing space planning to see if we have enough headroom for things. And then furthermore, we could set this up to show distribution like conduits and things like that. And that's what I did here in this 3D overall distribution, is I set it up to show the conduits. And we even have a roof plan. As you can see, it only shows the equipment on the roof. It is set up to not show anything below. You can see some of the roof details on the architectural model. And we have units, we have receptacles, things like that. Let me show you, we also in this project have some low voltage telecommunications. So if I go to a floor plan, first floor technology, you will see that it's similar. All in the same model, all in the same file. This information is all here. In this view, we've turned off receptacles, we've turned off our electrical conduits, we've turned off lighting. Now all we see is wireless access points, clocks, speakers, in this case with a school, teledata. And so all of these symbols, we've got cameras, we've got card readers. So all of the technology information is here. We have some conduits for technology. A 4-inch conduit is in the ceiling. It's shown here. And as we get into this IDF, you can see we have cable tray right here. Cable tray with fittings, a ladder kind of tray. And then we have a rack. And if we jump in here and do a 3D inside this room and zoom in, you can see that room. And let me pull in some of these walls. Move the section so we can actually see. You can see we've got our ladder, cable tray, our lights are hanging there. We've got this full rack. There we go. Hidden line, you can see some of that. We've got full racks. And so you can even do all of your technology and fire alarm plans in here, all in one model. Now the HVAC and plumbing are in separate models from this. We could link them in. Unfortunately, in this project, we were not given the mechanical model. We had to base it upon PDFs, but that works as well. But for full coordination and clash detection, it's nice to have everybody's 3D model. Let me show you some of the other schedules we have besides panel schedules. Now, if I go to the lighting fixture schedule, here's a listing, and we've set this up, we've customized this to show the columns that we want. What data do we want in this schedule? And now what we've got is a fixture type. We've got what lamp type, how many lumens, the color temperature, what load is each type, a manufacturer and model, basis of design, and kind of a short description. Now, there was a lighting designer on this project, so they filled in the rest of this information in their separate documents. But we wanted to get the basics in here for circuiting. This data is pulled out of the floor plans, or it's all pulled out of a database. So if I was to change this fixture type here, it would reflect that on the floor plan. Or if I change it on the floor plan, it gets reflected here. So it is all interact. Remember, I changed that from 30 to 40? Here it is. I could change it back to 30 from this schedule. It's going to be a change to all elements of that type. F24, yes, I want that to happen. There, I just did it. All of the floor plans show 30 VA, and the panel schedules and the MDB just got changed to 30 VA for each of those, and it just added them up for us, just like that. So again, very powerful. You can change things here in the schedule, and it changes it throughout the entire project. We also have mechanical equipment connection schedule. We like to list our HVAC and plumbing equipment in here. As you can see, we've got branch selectors, ceiling fans, fan coils, electric water heaters, a lot of fan coils, heat pumps, heat recovery units. It lists, we have it set up to list the voltage and phase and wattage, or VA. And then it even tells us what panel and circuit is it connected to. This all comes from the data in the model. We did not have to type any of this in separately into a schedule. We do type in our feeder separately, but we refer it to a feeder schedule. So a 20-2 would be like two number 12s with a number 12 ground in a 1/2-inch conduit. We refer to a separate drafting view of a feeder schedule. So that's what I can show you up here is electrical details drafting view. Here's a feeder schedule that we have created for copper and aluminum feeders. Now this is just lines and text. There's no smarts to this one, but at least we have these symbols that we can refer to in that schedule. We use similar nomenclature, and that leads me to our one line or single line diagram. Click on this. Now, I don't need to save this. This is again just a two-dimensional representation of our one line diagram that we drew. Now, instead of just drawing lines and arcs, we have created custom symbol families that have parameters that I can change. As you can see, I could change this to 1600 amps. I could change that to 2-pole or single pole. I also have the transformer, which is a separate symbol, and even in the internals of that is a symbol. So these are custom symbols that we've created. Even the little breakers here can be moved around. And then we drag this symbol of a feeder and just put it here, and it automatically blocks out the line behind it. Lines are easily moved within here. If I move this panel, I can drag this around. If I drag that like that, you can see that line's still connected. A lot of the lines are still connected to themselves. So I have some text that I can just line up, like right here, existing to Olympic Building. I can hit text up here, and if I go close, you can see a little blue dashed line is telling me that I'm lined up horizontally with that. Even this is a symbol we've created. So we've created all of these one-line diagram symbols that can be dragged onto a sheet and interconnected. We can even do this for a technology one-line diagram or riser. And so we have a bunch of symbols and text and things like that to create that type of symbol. We also have details, and some of these are either a drafting view or they can be what's called a legend. So we have our symbol list, for example, here, and a lot of it is just lines and text, but some of these can be symbols. Like for our single line diagram, we have actual symbols. We have different kinds of diagrams. There's elevator recall. My lighting control schedule that I was talking about is here. We can have different kinds of details, and they can be shared amongst different projects. And like I mentioned, all these things within our model are actually families. Now, I showed that before, but let's go down and look at the lighting fixtures. And you can see I've got these expanded, but there's a number of lighting fixtures that we've brought into. We have a company name in front of it. And then, for example, a recessed troffer in this case. Each time we create a new type, it lists it here. So we have an F24, F28, And each of these is a type or a subfamily, if you will, of the actual main family. So we have all these different families that we've created, and we, on the fly, duplicate them and make a new one and change its parameters. Same thing with the electrical fixtures. They call devices fixtures. So we have all the building blocks to create this electrical model. And we have our duplex receptacles here, a few different types. We've got our motor connections right here. So you can see there's a motor connection for every single fan coil in here. And each of these, if we were to take a look at the type properties, has the information for the load and the voltage and phase. So each is a type. And you just create these on the fly as you're creating your model, and then you circuit them up. We have electrical equipment like panels and switchboards. We've got vaults. We've got transformers, dry types, and pad mounts. We've got different panel boards. In this case, we have a bunch of different voltages, main circuit breakers, recessed, and all that. But again, these are all just families. But as you can see, even things like the architectural, the walls are a family. There's basic walls, curtain walls, stacked walls. Our wires are a family. So everything is families. Even pieces of the title blocks are families. Speaking of title blocks, let's take a look at some sheets. So down here, close families, we have sheets. There we are, sheets. And let's take a look at our third floor lighting plan. Now this is the actual sheet or drawing that has a title block, an engineer's stamp, and it has sheet name that gets reflected from over here. If I change the sheet name here, it changes on the sheet. And then we just dragged our lighting plan. Our lighting plan, as you can see, is just a separate piece that I dragged onto the sheet, and I can put it wherever I want. Here's the legend that I had. I can just, it's a separate piece that gets dragged onto the sheet. My title block, I can move it around. I have a north arrow that I can move around. So this is just assembled from all the pieces over here. If I was to go to the schedule sheet, you can see I have panel schedules that are just pieces that were dragged onto this sheet. I have separate distribution drawings that really highlight the overhead feeders for our conduits and shows their path throughout the building. And same thing with technology. For example, here's a number of details that we've just dragged onto this sheet. They can be moved around and placed on the sheet wherever you like. And to get these sheets onto a PDF, we have a little print button up top. And newer versions actually have a PDF export, which does similar things. But if I go to print right now, I can pick Bluebeam or whatever I want to print to, Adobe. And I can combine multiple sheets into one single PDF file, which is handy. And then down here, I can say, what do I want to print? I can have a selected views or sheets. I can have a named set. As you can see down here, I have all my views and all my sheets. I can turn off views and just look at sheets. Here's all my sheets. This one was called Tech ASI01. It was a recent change that we did. But I can just go to Electrical and Technology set. And as you can see, turn off the views. All of these sheets for my set are checked and saved as this name. So next time I want to print this set, I already have a saved named set. And then you can set up your actual printer, the size of your sheet, and what kind of zoom. We can hide reference planes. We can hide view tags that are unreferenced. And so there's a lot of variety that we can do, and then we can print that out into PDF. So that's kind of a quick run through of everything Revit for electrical. I hope you learned something. And if you want to learn how to do any of this, I have a channel full of how-to videos that you should check out. In fact, check out this video here that I'm popping on the screen if you want to see how to do some of this stuff. And thanks for watching. Until next time.